Hi everyone, another series. It's currently 2:15 a.m., probably 2:20 a.m. And honestly, it took me some time to think, like, how am I supposed to determine the polarity if I don't know what north or south is this? But then based on my logic, like, I don't know if this is right or not. I'll check with my teacher tomorrow because I have physics tomorrow. But if I'm not mistaken, this is positive and this is negative. So, but even though it's blurry, I can see that there's a dash over there. So then the current would move like this, like that, like that, like that, like that, like that. And look, it's straight. So meaning that, okay, so the solenoid moves up like that, and it goes down, 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 down. And remember that galvanometer is to detect the electrons, and current direction is always opposite from electrons. Okay, if you understand this, then you'll know that the galvanometer, since the induced current goes in here, then the galvanometer would be here, would deflect towards the left, because the induced current is going to the right. Okay, now by using the right grip rule, you can already determine the polarity, because now you know that the solenoid, it's like moving up, like the arrows are pointing up. So you use your right hand, the grip rule, and then you find that on your thumb that's pointing to the left right now, it's going to be north, because the magnetic field will always start from north to south, right? So which means that A is north and B is south. And if the way of how I understand this is correct, and I hope it is, because this is the answer, it's north and south. Okay, by using the arrow, show the direction of induced current that flows in the conductor and the direction of reflection of the galvanometer pointer. So like that. And then what type of induced current is produced when the bar magnet is moved in and out, okay, keyword, repeatedly through the coil of wire? Okay, so there's only two types of current. We know there's the direct current and alternating current. And what is meant by these two current? Literally the definition of your name. Direct means it flows only one direction, and alternating means it has alternative directions, so it flows in multiple directions. So if the bar magnet is moved in and out repeatedly, it means what? It's not one direction, there's multiple directions, so it means that it's an alternating current. Okay, last question. What happens to the galvanometer pointer if the bar magnet is stationary while inside the coil wire? So Lenz's law states what? That the induced EMF of something that opposes the flow of induced current, blah blah blah. So if the magnet is stationary inside the coil of wire, there's no relative motion to produce an induced current, which means therefore the galvanometer would be stationary.